The last objective of 1.1 is identifying whether an equation is conditional, a contradiction, or an identity. What it is that up until now, every single equation that you've solved has come up with something like x equals 10. And this is great. It means that when you plug 10 into your equation, that 10 is the only value that will make your equation true. So your equation is conditional on x being equal to 10, or the solution set is 10. But in reality, there's two other situations for linear equations. And one of those is that your linear equation can be an identity. An identity means that no matter what you put in for x, it will make the equation true, meaning there's an infinite number of solutions. The solution set will be all real numbers, which you could write out, or the shorthand from that, if you remember from chapter R, is the set of x such that x is an element of the real number system. So math has lots of shorthands for helping you write really complicated examples. And what will happen is that your equation will work out to x equals, or 0 equals 0. Or maybe it works out to x plus 3 is equal to x plus 3. Or 5 is equal to 5. It ends up with a true statement. So no matter what you put in for x, since on both sides you're adding 3, it will always be true. Or since 0 always equals 0, the equation will always be true. Or 5 is always equal to 5, the equation will always be true. The last type of linear equation is called a contradiction. It contradicts itself. It allows you to solve it, but the answer has no solution. And you show that by showing the null sign or an empty set bracket. And the indication when you're solving one of these equations is you'll get 0 equals 5. It contradicts itself. It's a contradictory statement. 0 can never equal 5, or it'll end up with 5 equal to 3, or x plus 2 equals x plus 5. You can never add 2 to a value and add 5 to that same value and ever get the same thing. So what will happen is you'll be solving an equation. You'll have no idea whether it's conditional, an identity, or a contradiction until you get to the end. So for example, if I work through this one, the first thing I'm going to do is distribute the 2. So I'm going to simplify my equation. I get 2x minus 6 minus 2x equals negative 6. When I go to collect like terms, I get 2x minus 2x, which means that it's 0. So I get negative 6 equals negative 6. Since I ended up with this true statement, it means the equation is true for any value of x. And if you wanted to go farther, I mean, the textbook likes to say that you can notice it by saying 0 equals 0, but I will say as soon as your left side is equal to your right side, you know that there's an infinite number of solutions, right? X is an element of the real number system. If you look at this next one, so this would be an identity. Identity, pardon my perfect writing. So the next one, same thing, you don't know it first. You go and you distribute the 3 through, you get 3x plus 3 minus 2x equals x plus 4. You go to simplify on the left-hand side, you can collect like terms. 3x minus 2x is x plus 3 equals x plus 4. And even here I can stop and say this is a contradiction. There's nothing I can add 3 to and the same number add 4 to and get the same thing. So I could stop here and call this a contradiction, or you can go further. I can say, hey, I'm going to move the x's to one side, then I'm going to subtract x. I end up with 3 equals 4. That's a contradiction. Or like the textbook likes to do, I can go even further and say that 0 equals 1. This is a contradiction. Contradiction. It means that there are no solutions. Oops, don't put a 0 in there. Let me just erase that. It means you can answer with an empty set bracket, or you can draw your null sign. The next example, I'm going to expand through again. I end up with 2x plus 2 minus 3 equals x. I'm going to collect like terms, so I get 2x plus 2 minus 3 is negative 1. I'm going to put my x's on one side, so I'm just going to move this guy over. Don't have to move too much. I get negative 1 equals negative x. And I'm going to divide by negative 1 to solve for x. And I get x equals 1. So this is a conditional equation. I ended up with x equals 1 being the solution, or the solution set is 1. And so for each of these examples, you get a different type of solution. But for the first one, so for an identity, it means I could pick any random value. So if I put in 0 for x, let's say, because that's an easy one, I would get 2 times 0 minus 3 minus 2 times 0. Does that equal negative 6? Well, 2 times negative 3 is negative 6. Yeah, it works. And in fact, I could pick any random number for x, and it will always make the equation true. So there's an infinite number of solutions. X is an element of the real number system. Don't write that one. Whereas when you end up with a contradictory statement, it means that no matter what I put in for x, this equation will never be true. Versus conditional, you'll end up with one solution, and it's the only solution that will make your equation true. All right, we're done 1.1. Get all your assignment done.